Good morning to all. My name is P. Niveditha. I'm currently working as assistant professor in Marri Laxman Reddy Institute of Technology and Management. Today I'm going to discuss about Perceptron training rules in machine learning. So what is meant by Perceptron? Perceptron is a built unit of ANN. ANN is nothing but artificial neural networks. Perceptron unit is used to build an AN system. Perceptron takes the vector of real valued inputs, calculates a linear combination of inputs, the output 1, if the result is greater than the sum threshold and minus 1 otherwise. The precisely given inputs x1 through xn, the output O represents O, x1 to xn, computed by the perceptron is output of x1 and so on xn equal to 1 if w0 plus w1 x1 plus w2 x2 and plus so on wn xn greater than 0 minus 1 otherwise, where each wi is the real valued constraint or weight that determines the contribution of input xi to the perceptron output. So this is the diagram of a perceptron. Here x1, x2 and so on xn are the input signals. W1, W2 and so on Wn is these are the weights. It represents the weights. X0, W. Initially we have to start with W0 and X0. And this symbol is represents the sigma. Sigma is nothing but summation. So summation of the input signals and weights. And this one is the activation. So activation is takes the input from the input signals and produce the output. So here O is the output if sigma I equal to 0 tends to n, wi x greater than 0, minus 1 otherwise. So one way to learn acceptable weight vector is to begin with the random weights, then iteratively apply the perceptron to each training example. Modify the perceptron weights whenever it misclassified as an example. This process is repeated, iterating through the training examples as many times as needed until the perceptron classifies all training examples are correctly. Weights are modified at each step according to the Perceptron Training Rule, which revises the weight wi associated with input xi according to the rule, where weight formula wi tends to wi plus delta wi, where delta wi equal to n. Here n means rate, learning rate of target output minus actual output of xi. So Perceptron Training Rule algorithm. Perceptron underscore training rule underscore x comma n. Initialize w of w and initial small random values. Repeat for each training instance. X2 tx belongs to x. Compute the real output ox equal to activation of summation of w comma x. If tx not equal to ox, for each wi tends to wi plus delta wi, where delta wi tends to n of tx minus ox of xi, and for and if and for until all the training instances in x are correctly classified, return w. So for take one example using Boolean gates AND, OR, XOR, NAND. In this session, I have to explain AND gate. So AND, first we have to take the truth table. A, B, A and B. A and B means A into B. So 0, 0, 0, 1, 1, 0, 1, 1. 0, 0 represents 0. 0, 1 represents 0. 1, 0 represents 0. 1, 1 represents 1. Initially, they given the weights W1 equal to 1.2, W2 equal to 0.6 and threshold value equal to 1 and a learning rate N equal to 0.5. First, we had to calculate the actual outputs and target output. The actual output is equal to the target output. Then only the condition is satisfied. If actual output is not equal to calculate, actual output is not equal to target output, so we have to again modify the weights. So in first step, a equal to 0, b equal to 0 and target is 0. So formula xi wi equal to x1 w1 plus x2 w2. So here x 1.2 into 0 plus 0 into 0.6. Finally, we get 0. So our actual output is 0 and the target output 0. So the condition is satisfied. Next, going to the second value. Same formula is repeated. So 0 into 1.2 plus 1 into 0.6. The answer is 0.6. So 0.6 is less than 0. So the condition is satisfied. So less than 0 means here it will come 0. So actual output 0 and target output 0. This condition also satisfied. And next, then third one. A value equal to 1 and B value equal to 0. So 1 into 1.2 plus 0 into 0.6. So 1.2 greater than 1. So the actual output is greater than 1. So the target output is 0. Here the condition is not satisfied. So we have to modify the weights. In this condition, we had to modify the weights. So how to modify the weights? Wi equal to Wi plus delta Wi. So where delta Wi equal to, here weight formula, delta Wi equal to n into T minus O by X. So in that we had to calculate the weights. How to calculate? First weight W1. So in W1, here we had to calculate 1 into 1.2 plus 0 into 0.5. So 0.7. In next W2. 0.6 plus 0.5 into 0.1. So finally we had to get W1 is 0.1, 0.7 and W2 is 0.6. So the modified weights are 0.7 and 0.6 and the threshold value equal to 1 and the learning rate n equal to 0.5. So again we had to start calculate the actual output equal to target output. Again A equal to 0, B equal to 0. So W1 0.7 into 0 plus 0.6 into 0. So answer is 0. So target output is 0, actual output is 0. So condition is satisfied. Next, second value. A equal to 0, B equal to 1. So 0.7 into 0 plus 0.6 into 1, 0.6. So less than 0. This condition also satisfied. And next, third one. A equal to 1 means 0.7 into 1 plus 0.6 into 0, 0.7. So less than equal to 0. This condition also satisfied. And finally, A equal to 1 into 0.7 plus 1 into 0.6. So 0.7 to 0.13. So this is greater than 1. So greater than 1 means it is equal to the 1. So this condition also satisfied. Finally, we had to calculate the weights according to using the binary, using the Boolean values and gate, actual target values both are same. So thank you.